Hmm. See, we're 1 minute past the hour. Maybe we can get started, and then we'll let others trickle in. Well, hello, everybody. Welcome to this wonderful Saturday's Green Energy Series. Today's topic is going to be about making the trades cool, and we're going to talk about technologies and tools and building techniques and efforts that state and federal government has put in place to all together work towards making the trades more desirable and generally cooler to be in. This is a free educational webinar presented by Solar Oregon. So Solar Oregon is an Oregon nonprofit. We have been around for 40 plus years. Our focus is on education, outreach, community, and advocacy. We have a number of events, including solar home tours. We have a Go Zero Energy home tour each year. And here, pictured on the right-hand image, is a solar winery tour where we tour solar facilities and visit vineyards. So what a great combination. And we do a lot of peer-to-peer education, among many things. And so yeah, that's Solar Oregon. We're a small, lean and mean organization comprised of 2 paid staff and many hardworking volunteers. If you like our work and like these webinars, you're encouraged to donate or become a member. You can do so with this link or by visiting the Solar Oregon website via Googling Solar Oregon. And feel free to ask questions throughout the presentation using the Zoom's features, whether it be in the chat or in the Q&A. My name is Edward Louie. During my day job, I work at Pacific Northwest National Laboratory as a building energy efficiency engineer. My hobbies include being a volunteer at Solar Oregon, building a off-grid zero-energy tiny house, testing energy efficiency technologies, and many other things that are related to energy efficiency. It's really a great passion to have. And just a disclaimer, the presentation does not necessarily reflect the positions or views of Pacific Northwest National Laboratory, the U.S. Department of Energy, or Solar Oregon. I've made best effort to convey facts and information accurately when it comes to making career choices or investment decisions. You are encouraged to do your own research and your own calculations before making plunges. So as shown in the title, this presentation is about making the trades cool. We'll look into ways that buildings are being built today that are different from the past. Buildings today are more built in controlled environments. More and more of them are being built in controlled environments. That makes it more desirable to work in if you're working in the home building industry. Codes are driving better home designs, and those better home designs are not just to make homes more durable and efficient, but many of those designs are also making them easier to build. So that's very good. The materials that are going into homes are also generally easier to apply and install. So that's very good. And there's more free education content that is entertaining and desirable to engage with than ever before, and more of that education content is coming online every single day. It's a wonderful time to be alive. And there's also better tools in every single trade in construction, and these tools make it easier to perform the tasks needed to do on a day-to-day activity, whether it be making connections or application of material. And there's a lot of money and resources being invested towards the workforce in the construction trades. And this money and resource could be spent on you if you choose to go into the trades. So that's wonderful. And many organizations focused on helping specific groups that are generally underrepresented in the construction trades, whether it be women and BIPOC groups. And these organizations really help like mentor and recruit and show folks in these groups just what the trades are and how they can be a good career. And lastly, we'll look at the pay scale in the trades, and they're pretty high. So it's a career that can definitely make a living, and we'll jump to some conclusions after that. And so again, homes are now increasingly not built in the freezing cold, hot sun, or pouring down rain anymore. And the reason for that is due to the desire for efficiency and higher quality. And then also, some of this is also driven by a lack of people in the trades. And so one worker cannot actually build the workforce in its current size is inadequate to build the housing stock that is desired. And so as a result, many construction companies have resorted to the use of machines and robots and automation and factory processes to allow workers to be more efficient and to build homes more quickly and in greater numbers. But these factory environments also means that if you work in a panelized wall factory, then you're no longer framing homes in the freezing cold or hot sun or pouring down rain. Instead, you're doing this type of framing with the aid of robots to help with processes that are very monotonous or backbreaking. And so you're just helping robots along in a controlled environment that is air conditioned in the summer and heated in the winter. And there is a flushing toilet and a break room that actually is lit. So it's a nicer environment to work in. And both big builders and small builders are making heavy investments into offsite construction techniques. And we can take a look at some of the advantages of offsite construction. So we'll take a look at the right video, which shows a panelized wall and modular roof home built starting from the slab foundation all the way to completing the roof in just one day on site. So this is the when I said like there's a lot less work being done in the beating sun or the pouring rain, this is what I'm talking about. You can get from foundation to roof in just one day. So let's take a look at this video. So at 7 in the morning, you can see this home is just a slab, nothing. And they're already craning in entire wall panels. And by mid-afternoon, they've already have the entire first floor and the floor system for the second floor built. And by late afternoon, they're craning in the roof. So by 3 p.m., it's pretty much done. So let's get out of this. What a great time to be alive. Your previous generations of framers would probably be kind of jealous that, this is the way framing can be done today. And the video on the left, we have some clips of that show what it's like inside a panelized wall factory, where to show off just how much robots and machines are doing, and then how much work humans have to do. So let's take a look at that video. So we'll pause right here. So you can see like there's framing stations and the wood is already all pre-cut, and humans are just helping with placing the lumber and doing some amount of nailing. there's still, as in this last clip, somebody to grade lumber, but once the lumber is graded, machines are used to cut and notch the wood. This machine is applying a sealant that when it cures, it will be a gasket that drywall, when this wall is closed up with drywall on the inside, the drywall will seal against this gasket and therefore prevent heat and air leaks through the gap between the framing wood and the drywall. And this robot is able to place this gasket perfect every single time. You can imagine on such long runs of caulking, if you were to apply it, one, your wrist might get tired, and two, you might wiggle a little and not place it perfectly straight. And then same thing, here's a video of a robot nailing off sheathing. Modern codes require the sheathing to be nailed off at like 3-inch on center or 6-inch on center, and being able to accurately place these nails consistently in accordance to the code required nail pattern is kind of a tedious and challenging task. That's, it gets boring really fast, but machines can do it accurately every time. So they have machines do it. And this factory makes stuff like windows in-house. Not every panelized wall factory has that level of vertical integration. Some of them will just buy the windows and then install the windows once the window is already fully assembled at the window factory. So that's that video. All right. Let's move on. All righty. So better ways to build. Again, this is driven by both energy efficiency codes, and increasingly it's been driven by carbon. Okay, let's go back to the slideshow. Increasingly, it's being driven also by embodied carbon reduction goals. So like the slab detail in the right-hand side is a concrete-free slab. Now, why would anybody want to do such a thing? Well, it's mainly driven to reduce the amount of embodied carbon in the building, because concrete is a really high embodied carbon material, but it has the advantage also of being easier to install, because I don't know about you, if you ever seen people finish and work with concrete, it is backbreaking work to, both get into boots and trudge through the concrete when it's wet. And it's very backbreaking work to float and finish concrete, especially large pours of concrete like a slab. And so it's not very desirable work. And oftentimes that slab is built before the framing structure around it is already installed. And so you're, again, trying to finish and pour concrete out in the open to the open sky. And it could be really hot or really cold. And you have to work in those elements. Versus a concrete-free slab, how it's often built is that this stem wall here is the only concrete element that is built, and then the wall elements are then erected or craned in place. And then once the roof has been installed, then you go back in, and now you're inside an enclosed and protected space. And then you're pouring in the gravel, and the gravel is often brought in using a conveyor belt type chute. And then you run a plate compactor to compact the crushed gravel. And then these layers of rigid foam board, these foam boards are really lightweight and easy to work with. And so the next instructions is to then like lay down the foam boards, which is much easier to work with than pouring concrete. And then again, the vapor barrier layer is just a roll that can be unrolled and then stretched and then taped at the seams. Then laying down the 2 layers of plywood that's also much easier to work with than pouring concrete. And so overall, this is a much more user-friendly construction detail, in addition to having the benefits of being low embodied carbon, better for the environment. So things are going hand in hand. And then on the left-hand side, we have a construction detail to make a conditioned attic. So meaning that this middle part of the attic is at the same temperature as the living space down below. This is very good because if you were to put mechanical equipment such as a furnace or an air conditioner or a heat pump up here, that equipment is not exposed to the extreme heat or extreme cold of the outside. And so it's more energy efficient, the equipment will last longer. But in addition to that, the people that have to, the HVAC techs that have to do the install and servicing of the equipment throughout its life, it's a much nicer space to work in. And then often this is also a space where as a homeowner, you can put your seasonal supplies into, and in storing seasonal supplies in a conditioned attic is much nicer for the seasonal goods than storing it in unconditioned attic. And then also this attic detail where the insulation is placed on the roof plane to create what's called a compact roof system. This is much nicer to install this insulation than the alternative, where the insulation is installed on the attic floor. And when it's installed on the attic floor, if you're an insulation installer, you have to feel for the floor joist and then hold on to the roof rafter so you're not falling through the ceiling. And so you have one hand on the attic joist, and then you're feeling for the floor joist for your feet, and then you have one hand with the insulation blowing hose, and you're trying to navigate the attic that way. And then also the attic at that time could be 130 or 120 degrees in the summertime, and it could be near freezing or below freezing in the wintertime. So it's a really inhospitable place and not very nice to work in. Whereas applying the insulation to the ceiling to the roof rafters in this design, you're standing on a subfloor and blowing the insulation into these cavities here. And so you have no risk of falling through the ceiling. And also, once it's blown, then instantly this place starts to cool down or warm up. And so it becomes a nicer place to work as you're insulating the attic. So that's very good. Code is also driving these changes in home design. So in 2021, the state of Oregon adopted this change in duct design code. So now all new duct systems, air handling equipment, and appliances shall be located fully within the building thermal envelope. And so code is requiring the ducts and the mechanical equipment to go inside inside the thermal envelope. And so as a result, then roof and attic designs are changing. So more homes are built this way now, with the insulation against the roofing plane and not on the ceiling plane, in order to allow the mechanical equipment to be inside the conditioned space. And that's very good. There are alternative ways to do this, such as installing the ducts and the mechanical equipment inside a drop ceiling, or in a modified truss attic where there's a section of this truss that allows the equipment to be inside conditioned space. Some are using the exception here. There is a deeply buried duct allowance, so that if you were to install the ducts laid flat against the ceiling plane and then bury it deeply with insulation, that is still allowed, but it's not that often done, because the amount of insulation you need in order to cover the ducts to that proper code is quite a bit of insulation, and it's just easier to build these with some of these other techniques, particularly this ducts in unvented attic method. And then for two-story homes, ducts between floors is now a really common way to do this design and meet this code requirement. So we have the better and newer building construction techniques driven by code and by labor shortages needing more automation in order to maintain the housing output needed. But besides those two things, there's also better materials. These modern materials are easier to apply. Here's two examples. In many decades prior to recent times, the way to put a weather-resistant barrier into the wall assembly is to wrap the house with house wrap. And a common house wrap is Tyvek. But this is done after the home is framed and sheathed. And so the Tyvek is often applied using ladders or these platforms that run on pump jacks. And you're applying this when it is raining or windy outside. It's not very nice to do. And oftentimes the application is not very high quality. An alternative to this method of applying the weather-resistant barrier to a home is to use a sheathing called Zip. And Zip is a sheathing that has the weather-resistant barrier applied at the factory. It's impregnated onto the OSB sheathing. And so each sheet comes to this job site with the WRB material already applied. And all there is to do is to just tape the seams, and you would have a very clean and continuous weather-resistant barrier that will not flop or peel off in high winds. And as you can see, even before it's had time to age during construction, the Zip sheathing weather-resistant barrier is faring a lot better than the house wrap. That's one example. Another example is in the insulation trade. In decades past, the most common way to insulate walls is to fill the cavities with batt insulation. Well, batt insulation, you need to take an insulation knife and cut around and notch the insulation batts around electrical boxes, and also split the batt so that it will be able to cover wires. And these tasks are often not done well or done at all. Like, for example, in this case, they probably should have split the batts in order to then weave it around this wire here, but it was not done. And this is actually quite common because it just takes a lot of time. And the installation is often paid by the sheet or paid by the bag or paid by the job type work. And so, there's an incentive to work fast and sometimes skimp on quality. And same thing with this pipe. This pipe is another obstacle that's very difficult to work around. There's not really a good technique. And so the result with batt insulation is lumpiness and voids, and these areas that have no insulation. And so as a result, the effective insulation value of a wall that has been insulated with batts is, much less than the actual R value that is written on the bag or packaging of the batt insulation. Due to how difficult this is to apply, and also the greater demands by energy code to actually have effective R value, not just the R value written on the bag, more homes are now insulated using a blown-in insulation system. And so this is dense packed cellulose. And as you can see on the right-hand side of this image, the insulation perfectly fits into the stud bay, perfectly fits around the electrical box, and there are no voids. So now you have a very, very high chance that whatever the designed R value is for the cavity of the wall, that is actually the R value you can actually be able to achieve in real life. And so this insulation is much easier to apply, much faster to apply. You don't have to cut bats and stuff. You just poke the insulation blowing hose into the netting and then blow the cavity, and then now you're off to the next one. And it requires touching the insulation much less. And so it's less scratchy and less tedious work. So if you are working in the insulation industry, these changes are very welcome. For painters, paints and glues have become much less smelly and less toxic. Many paints now have low or no VOCs. So this is great for workers. It's safer to work with. And yet these low or no VOC paints are still very durable. And so for the customer who's interested in longevity, this is still a very durable paint. So we've covered the kind of advances in techniques driven by codes or labor shortages and advancement in materials. There's also great advancement in the education material in construction. The education material that comes online each day and has been available for in the last recent few years is very good. I mean, I call it edutaining because like it's entertaining to engage this content. It does not feel like, you know, boring school. And some examples of really good resources is the Building America Solution Center and the Building Science Education Solution Center. Pictured here is the website of Better Built Northwest, which is a great resource that's put together by industry partners here in our Pacific Northwest group. Green Building Advisor is a really good website to access this content. There is some free content available, but if to get the full access to the Green Building Advisor website, I think it's like $140 a year. So, you know, you divide that out by 365 days, it's, you know, nearly free. That's a really good resource. Building Science Corporation is a website that is run by a founder called Joseph Lestibrick, and he is kind of been well regarded as the founding father of building science. And so this is a really good resource. Building science is now more and more important because as we build homes that are more and more well insulated and airtight and high performance from an energy perspective, we still want the home to be durable. And therein lies a bit of a challenge, is that traditionally the reason why homes that are 100 years old or more are still in good condition is because they bled a lot of heat out through the uninsulated walls, so that everything that got wet has an opportunity to dry quickly from just the heat leaking through the wall assembly and the roof assembly and the floor assembly. But now that we're filling, you know, all these cavities with insulation and sealing it down, the amount of heat that's leaving the building is, you know, a tenth or less than a tenth of what it was before. And so now everything exterior the insulation now needs to be able to drain, and it needs to be made from different materials that are more waterproof and resistant to rot. And they need to be installed in a much more careful manner so that the flashing and draining occurs. And so this is all related to building science, and the importance to learn this new science is driven by just we're building homes differently now. We're no longer having homes that are, you know, you don't need to care that much about how it's built, because, well, if any mistake is going to result in some leaks, but it'll still dry because, you know, there's so much heat leaking through every structure. Now with more insulation, you can't make those same mistakes and get away with it. Whole Building Design Guide is a website that's great for engineers and architects, really and builders that are interested in designing homes that are high performance and easier to build. And so that's a great resource. And then there's also great YouTube channels. And YouTube channels is, in my opinion, kind of the hallmark of edutainment. You can just sit back and instead of watching, some TV show or movie, you can watch, go down the YouTube rabbit hole and watch a bunch of edutaining videos from the HVAC school or home performance. And these folks make very good content that's both educational and entertaining. I mean, think about it. Matt bangs wood. That's gonna be entertaining. And this is just a small sample of the YouTube channels that have really good construction content and that's both educational and entertaining. And from all this knowledge sharing, you get to, as a person entering the trades, you get to learn from people who have figured out how to do things the best way, so that the new folks in the trades, you get to work smarter, not harder from day one, because there is such a wealth of knowledge to learn the best techniques right from the start. Here are some examples here. So like on the right-hand side is a stair climbing dolly that allows one to not have to even effort to pull a dolly up a staircase or carefully, bounce the dolly down each step in order to move a water heater into a basement. It's a really cool tool, and we can watch this video and see how it works. So it's got a motor, and you just control it, and it will naturally, in a very controlled way, motorize the dolly up and down each step. So you can have a very controlled way to manage this heavy water heater. And so that's one tool. And then here's another video on how to operate a dolly in order to get a water heater into a very difficult location without ever have to pick up the water heater and break your back doing it. So we can watch this video and see how this guy does it. So this tool has a strap of a rubber or like friction material on the strap. And so this is an 80-gallon water heater, so it's pretty heavy and huge. And so he gets it on the dolly. Then he moves it out to his work truck to use the tailgate to jack the water heater up higher on the dolly. And then because of the friction on this rubberized strap, he's able to keep it from sliding back down. And the reason why he needs this water heater high on the dolly is because he needs to actually be able to hop over that wall there in order to get this water heater into that alcove. And so the rubber strap allows him to even carry the water heater, and each time it goes up each step, it bounces a little bit, but it doesn't slide back down. And so then he just turns it. And bam, he can use the dolly to help set the water heater right into the drain pan. And wow, this is great. Like, I've seen a lot of these water heaters in such alcoves, and I have no idea how they got it in there. And now with this video, I know how they got it in there, and it's really slick. So anyways, these are techniques that, in generations past, if you were lucky to learn from somebody who could teach you such a technique, then you were lucky. And if you were not lucky, then, well, you just have a very bad and sore back without having to work that many years in the water heating installation career. But now the types of videos are available online, and it's Google search makes it easier to find. And so What a time to be alive in construction where you have such access to this type of knowledge. Okay, let's go to the next slide. And then in the world of connections, again, technological advancements to make the world of being a plumber that much easier. Very rarely now is there a need to do soldering or use messy glues. Now, pretty much all new plumbing is done using press type fittings or expansion type fittings. And these press and expansion type fittings utilize these specialized tools that make reliable connections every time, regardless of whether there's water in the pipe or whether it's really hot outside or very cold outside. It works reliably. Versus in the past, for example, with soldering pipe, you needed to stick paper towels or napkins into the pipe in order to, like, so wake up the water in the pipe, because when you solder the pipe, the water that's in the pipe will turn to steam and then push out the solder, and then you'll never actually be able to get a good solder joint. Those days are gone. You don't need to worry about that being an issue. In the past, with messy glues, they only work well under certain temperature conditions. So it's very hot or very cold outside, the glue may not set correctly. And so then, you're going to get a weak joint that'll end up leaking later. That doesn't happen with these press and expansion type fittings. You can do these fittings at any condition, and it'll still be a very reliable connection. And they're much easier to use and apply. In the HVAC world, again, in the past, the connections were made with either a manual hand flaring tool for flare connections or a torch in order to make braze connections. The trouble is, a lot of these connections are made in attics or crawl spaces because, well, a lot of mechanical equipment is in the attic or crawl space. And could you imagine, like, being in such a cramped and tiny place, and you have to worry about not falling through the ceiling, and then also carrying a big heavy tank of gas up there in order to make the braze. And then, oh, by the way, when you're brazing, you're also burning all the oxygen in that vicinity, and that same oxygen is what you need to breathe and stay alive. And then when you braze, there's also fumes that come off, and those fumes are in the same little tiny airspace that you're in. So it's not very safe, very inconvenient to do, and that's why the industry is moving away from that, because it's an undesirable connection technique. And so technology has moved on, and now we have press fittings that can be done with no flame. It's faster and it's just as reliable. So what a great time to be in HVAC. You don't have to suffer through, the brazing process. And then when it comes to flare connections, in the past, you had to use a manual flaring tool. And that's fine if you had to flare like 2 or 3 or 4 flares per day. But if you're doing high production, man, at the end of the day, your wrist feels like it's going to fall off your body, because you're twisting that manual flare tool so much that it's just repetitive stress injury waiting to happen. Well, now we have battery powered flaring tools that make a perfect flare every time. So you no longer need to suffer through that process either if you entered the trades. So awesome. And so in addition to kind of the advancements in construction, there's also a huge amount of money put into development of the workforce in the trades. In Oregon, a few years ago, Senate Bill 1545 was signed into law. It's known as the Future Ready Oregon the bill, and it put $200 million into new and existing programs that connects people to job training, apprenticeship, and education, with a focus on supporting underrepresented groups. Private companies like Lowe's have also dumped a bunch of money into workforce training. And then on the federal side, the Infrastructure and Investment and Jobs Act and the Inflation Reduction Act together has an investment totaling $75 billion dumped into building up the green workforce. And so that's really a lot of money. Oregon is getting 5.6 million under just the IIJA Act, and we're going to be spending most of that 5.6 million on building up the workforce for energy raters and energy auditors, because it's now really important to not just build high performance homes, but test and verify that homes are high performance. There's a great phrase, if you're not testing, you're really just guessing. You have no way of really knowing for sure. And so there are tools such as blower door, and this is a tool that pressurizes a home to a standardized pressure difference between the inside and outside, and that pressure difference is 50 Pascal as a common metric. And with that pressure difference, it measures how many cubic feet per minute of air needs to be moved in order to maintain that pressure difference. And then you normalize that to the volume of the home or the building, and that measures just how well did you seal all the cracks and leaks. And if you did a bad job, then you failed the test. And then you can also then use tools like a fog machine and a smoke stick to actually locate the leaks and know where to go back and fix and seal in order to bring down that leakage, so that now the home is actually as high performance as it needs to be to meet the code requirements. This type of skill is greatly needed, because now we have codes that aren't just, oh, well, it says there that you need to have 3 air changes or less, but no one's testing, so who knows what it actually is. Now the code has gotten to the point where you actually need to test to prove that it is, as airtight as, the code requires. But the number of people that have been trained to do this type of diagnostic and testing and know how to run this equipment is lacking in the state of Oregon, and it's actually lacking nationwide. And so there's a big push to try to train up a workforce that knows how to use these instruments in order to measure and find leaks and thermal gaps and missing insulation. One such tool is a thermal imaging camera, and I have one that is attached to my cell phone, and this module is only like $400, and for a construction company that is chump change. And you can issue these to your workers, and they can attach to their smartphone and go around and find areas of missing insulation. Like, for example, like in this house, there's a little line there that's blue, and that's because the top plate of the wall is an area where you cannot stuff insulation, and so then there is a thermal bridge there, and it shows up as a little blue line in the thermal image. And so knowing the techniques on, like, well, how do I interpret what I'm seeing on the screen? That is training that needs to be done, and it's training that many states are investing in to get that workforce up. So it's one thing to have a lot of money available for training up the workforce, but oftentimes it takes a friend, a coworker, someone who can like encourage you to join the trades and tell you about how cool it is in order to actually convince you to do it. And for a lot of women and Black, Indigenous, people of color groups, there's just no one in their circle of influence that can be that can have that conversation, be that mentor to tell someone that the trades is a good career. And so there are organizations that specifically are working to target these underrepresented groups, and to really hold people's hands and show them the way and get them into this construction training programs and apprenticeships so that they can get their career started. And this is one example organization, Constructing Hope. This one is a program that helps people get into pre-apprenticeship construction programs. And sometimes it's necessary to have a pre-apprenticeship program because for some people, like due to their family's background, circumstances, difficulties, like even life skills, like, showing up to the job site on time each day is kind of a challenge. So like, you need, for some, there needs to be a mentor to like, hey, like, getting dressed in the morning, brushing your teeth, getting to the job site on time each day. That's really important. It's to show that, you really care about this job, that you're a professional. And so, and then some people, like, math skills is a real challenge. I thought I was good at math growing up, and then when I got to college and started taking the advanced math, I realized that math is really not my favorite thing anymore. And for some people, they hit that wall earlier in life, and so, these pre-apprenticeship construction programs also help people with math and other kind of skills that you need in order to be successful in construction. Women is also a highly underrepresentative group in the trades. There is an organization called Oregon Tradeswomen that is working to show women that a career in the trades is viable. I follow some YouTube channels and Instagram channels run by women who are plumbers, women who are welders, and women who are drywallers. And it's really great to look at the comments and see that, many other women are commenting, saying like, thank you for being an inspiration. I never knew that this was something that like women did, and to see like, another person do this who's also female, like, is a really encouraging thing. And so I think, we need organizations like this to help women see that there are other females in the trades, and that it is a cool thing to do. Leaders Become Legends is another organization that's helping Black, Hispanic, and Native American folks see that the trades is a cool career to be in. There's an organization called it's African American Alliance for Home Ownership, and this is a organization that helps traditionally a group folks that have never owned a home understand how to get into the home ownership process. But one of the things that they're also doing is helping people be interested in becoming energy raters, whether it be at the professional level or for new homeowners to understand, things that they can do themselves to do like a DIY home energy assessment. So they're doing both of these things. And as I said earlier, like with like the blower door, that's a skill that professional home energy assessment people do. And it takes some training to learn how to use that tool. I mean, it's not right. Once you learn it, you'll realize it's not that hard to use. But if you've never used it before, it can be kind of intimidating. And so, this organization is helping people, gain those skills and become a certified professional home energy assessor. So that's really cool. Oregon is also fairly innovative. In fact, this first bullet point, we're very innovative. We're the only state that does this. Is that Oregon created a limited specialty plumber's license that only requires an 8-hour class and a 3-hour 52-question open book exam and $100 application fee. If you pass this 3-hour 52-question open book exam and take this 8-hour class, you get this limited specialty plumber's license that enables you to work for a company to install water heaters and other limited specialty plumbing. And this is really cool because in previous green energy series, I talked about heat pump water heaters and how heat pump water heaters save a lot of energy, and it's a really important technology. Well, there's a bit of a shortage in plumbers to install those heat pump water heaters. And so that's a major barrier to adoption. And Oregon recognized that. And so that was one of the main motivations for creating this limited specialty plumbers license, is so that more people can quickly become licensed professionals to do water heater installs and water heater replacements. And that has contributed to why Oregon is one of the states with the highest heat pump water heater adoption, is that we just have more people that are able to do that install. We've created other limited license, such as the limited renewable energy technician. And this is a 2-year paid apprenticeship with and the 2 years is half the time it normally takes. So if you get rid of the limited and just be a full renewable energy technician, that's a 4-year apprenticeship. And so by creating a limited path, which means that you're limited to solar energy systems that are, I think, under 40 or 50 kilowatts, which is still a pretty good size renewable energy system. But that's kind of the limit. But that means you can do pretty much all the residential solar installs and even light commercial installs, no problem. And it's half the time. And so, that's really good. With half the time, you then get a professional license to, become on your own renewable energy technician. And later we'll look at the pay scale of some of these careers, and it's pretty good. And then Oregon also has a limited residential electrician's license. Again, that's half the time. Normally it's 8,000 hours or 4 years of on-the-job apprenticeship training. This one's half the time. And so these are really kind of good ideas to enable the workforce to have shorter paths to becoming a licensed professional. So salaries. Here's some of the salaries for example, for the electricians on the right and renewable energy technician on the left. $34.50, and then somewhere between the mid 30s and mid 40s. I mean, that's pretty good. People who go to a 4-year college and then take on student loan debt come out and they don't make that kind of money. So I mean, you get paid on the job apprenticeship training, and then after your apprenticeship you're making this kind of salary. That's pretty good. And then so those are kind of like listed salaries for the industry based on these apprenticeship listings. I did a quick search to look at actual job postings here in the Portland area to see what kind of salaries we're talking. Okay, PV installer, around $23 to $27 an hour, and this is for a kind of an entry-level position. And so, as you said, 2 years of solar installation experience. So once you're out of that apprenticeship, which is 2 years, you instantly drop into that, and that's your pay. For HVAC, the heat pump store is hiring heat pump installers, and they pay $90K a year. At the earlier slide, I talked about how increasingly the framing of homes is done inside factories. If you're wanted to become a manager at a panelized wall factory, there's a job out in Hillsboro by Par that pays around $100K a year. So that's pretty good. And qualifications: high school diploma and some experience. I mean, to say that you need a college degree in order to make 6 figures is no longer true. Like there are high school positions in the trades that pay 6 figures or more. So very, very good. And these are also hourly for these 2 jobs. And so if you want to work overtime, when there's always overtime in construction, then that's time and a half pay. And so you can easily roll into the 6 figures easily. So that's very good. And so the conclusion is there's widespread respect and regards for the trades as an important career path. And now there are better systems, designs, products, and tools that together make working in the trades much more comfortable, safe, and desirable. It's no longer a career where it is like the norm to, destroy your body and, work in inhospitable conditions. Like that is no longer the norm or the culture. And the trades paid really well, and they are hiring. That's conclusions. And then the next green energy series, we're going to look at, it won't be me presenting, it'll be someone else. And the topic is a day in the life of a solar installer or a solar company owner. And so we'll find somebody who can speak about that and give you their firsthand experience on what it's like to have a career in the PV industry. And I'm really excited for this green energy series. That's all we have for this one. Questions? Do we have questions? There's a question about make a video playlist. Certainly. And then also we can send out this slide deck, and then you can click on the videos and watch them yourself. I'm not seeing other questions. And you can also unmute yourself and ask a question.
Edward, there are a few in the Q&A. There
are. There we go.
Yeah.
There we go. Okay. I like the installation photo, but it leaves me wondering what they're doing.
I think that was at the very beginning, your opening screenshot, that that Abby picked a photo to go with this topic.
Oh, you're talking about this one?
Yeah.
Oh, I think they're installing panels or getting them aligned, so then they can put the hold down washer and bolt and then torque that down. That's what's happening here, and there's a supervisor supervising them. Yeah. The roof design using 2x12 for the rafter that uses top quality lumber and farms heat bridge. Is there something greener? Okay, so you're talking about this detail here, where you're saying that there's a thermal bridge through the 2x12. Indeed, there is. If you want to break that thermal bridge, you can then put a layer of rigid foam either on the underneath side or on the top side, and then that will form a thermal bridge to break the framing wood issue. But when you have 2x12 is whatever, like, it's not actually 12 inches, it's like 10.5, I believe, or something like that. I mean, it's still a decent amount of insulation just for the wood, just because it's so long, or such a wide piece of wood. But yeah, if you want to go even better, that inch of or 2 inches of exterior of rigid foam insulation will do a lot for thermal bridge. Is there a number of solar installers we need in Oregon? I don't have an exact number. There are such job statistics on, like, what we need in order to reach like our solarized targets or decarbonization targets, or number of homes we need to build in order to meet the housing demand. There's all sorts of those stats. I don't have them at the top of my head, but they're pretty easy to find on Google. There's a shortage of people in every single trade, whether it be solar installers or framers. Every trade has shortages right now. Okay, well, it looks like we've hit all the questions. If there are other questions, feel free to chime in. Otherwise, have a great rest of your Saturday then.
Thanks, Edward. We'll see everybody next month. Have a good day.
Awesome. Okay,
Bye.
great.